Today we are looking at inverse functions. Inverse functions. And we're going to go ahead and look at inverse functions in a multitude of ways. We are going to take a look at how to find it with tables, with graphing, and how to do it with an equation. So we're going to start with what is an inverse function, and it is a function that undoes the action of another function. Okay, so we are going to look at how to find the inverse. So given an equation, we are going to figure out how to find the inverse of that equation. And like I said, we're going to use 3 different methods. So our first method, we're going to use a table. We're going to go ahead and look at a function of values, and we're going to look at it as an XY table. So our original function has an x of -2 and a y of -3. It has an x of 0 and a y of 1, a 1, 3, and a 2, 5. Okay? And we want to go ahead and find the inverse of this function, which is f of -1 to the x. And that's how we look at it. And the way that we do it is very simply. We simply switch x and y. So with our new function, our x and y of the ordered pair -2, 3, the -3 is going to become our x value, and our -2 is going to become our y value. So our 0, 1 is going to become 1, 0. Our 1, 3 is going to become 3, 1. And our 2, 5 is going to become 5, 2. So you simply switch them. That is our first method of finding the inverse. Method 2. And our second method is going to be graphing. Okay. And what we're doing when we're graphing is we are actually making y is equal to x, which is our main line down the middle. And we're reflecting across that. And that's what we're actually doing when we're finding the inverse. So we're going to go ahead and do a quick graph. And we are going to take a look, and we're going to do a y equals x line right down the middle. We'll make that one a dashed line. And that's what we're going to be reflecting the line across. Okay. And so we're going to go ahead and plot the equation f of x is equal to 2x plus 1. So we're going to start by doing the original equation. So we're going to plot our y-intercept at 1, and then we're going to move our slope up 2 and 1 to the right. Up 2 and 1 to the right. Up 2 and 1 to the right. Down 2, 1 to the left. Down 2, 1 to the left. Down 2, 1 to the left. And we're going to go ahead and make that line that represents the equation f of x is equal to 2x plus 1. Now, basically, if I were to fold my graph on my dashed line like this, that is what I'm going to reflect, because it's y equals x. I'm going to reflect the line of my equation over that line. So if I were to put paint on here and go ahead and fold it and open it up, I could see where that paint is going to lie. So for example, when I see this guy right here, right, is the point 0, 1, then I'm going to reflect it across, and that's going to be the point 1, 0. The point 1, 3 becomes the point 3, 1. The point 2, 1, 2, 3, 4, 5 becomes 5, 2. So as you can see, I have a slope of up 1 and 2 to the right. Once you see that, I can go up 1 and 2 to the right, and I can go down 1 and 2 to the left, down 1 and 2 to the left, and I can continue that slope for my inverse line. Then we're going to go ahead and connect those. And we now have the graphical representation. And as you can see, if I were to fold that over on the line y is equal to x, you can see that those are going to be on top of each other. So that's how we graph it, is we reflect it across the y equals x line. Okay, let's go ahead and look at our last method, method 3. And our third method here, just going to go like this. Our third method here is going to be algebraically. Okay, so we're going to start with that same item, and we're going to follow some rules. Set f of x equal to y. So we're going to use the same equation, and so we're going to have y is equal to 2x plus 1. So all I did is, instead of writing f of x, I wrote y. Step number 2, switch x and y. So we're going to go ahead and switch x and y here. So we're going to have x is equal to 2y plus 1. Step 3, we are now going to solve for y. And that's just going to be using our normal order of operation. So we are going to subtract 1 from both sides. And we have x minus 1 is equal to 2y. I'm going to flip it around. I like my y first. So 2y is equal to x minus 1. And then I'm going to finish up by dividing every single term on both sides by 2. So that leaves me with y is equal to 1/2 x minus 1/2. And then finally, the last step, number 4, is you are going to rewrite, replacing y with f negative 1 of x. So we're going to finish up here with f negative 1 of x is equal to 1/2 x minus 1/2. And that tells you that this is the inverse function of the line y, or f of x, is equal to 2x minus 1. So this, ladies and gentlemen, is inverse functions and how to find them, both using a table, using graphing, and algebraically. Let's go ahead and practice on our Desmos